with a concept video on measurement and errors. And we're going to today, for the first part of the video, for this video, we'll be focusing only on the units and the errors. We don't want to make a video too long to annoy. So let's start with the SI units. So SI units or base units are 7 fundamental units on which all the physical quantities in science are based on. So they are length. So I'm going to talk about physical quantities first, and then I'm going to talk about their units. So length, mass, time, 3. Then current, amount of matter. This one is used mainly in chemistry, amount of matter. Then you have temperature. And the last one, which is luminous intensity. You will see this particular one if you will be doing space topic. Now, let's talk about the base units. So length, any kind of length, distance, height is always should be measured in meters if it's a base quantity. Mass, kilograms. Mass and weight are different things, so don't get confused. Time is seconds. Current is amps. Amount of matter is mole. So wherever you have current related things like charge, voltage, you should convert everything into amps because amps is the base quantity. Temperature is Kelvin, and the luminous intensity is candela. So the candela is a unit to measure the luminous intensity of anything that emits any kind of light, measured used to measure luminous intensity of stars, of light bulbs, all of that. Okay. Now, how do you use these base quantities and convert them into the most common units? So the most common units of quantities like force is newtons. So the actual science word for that is derived units. So the force derived unit is newtons, but your exam questions would want you to convert derived unit into the base quantities. How do you do them? So the first step is look for a formula in your equation sheet or basic formulas like I'm using mass times acceleration. So force is mass times acceleration. That's my first step. The second step is convert everything in the formula into its base units. So we know the base unit for mass is kg written. Acceleration is now base unit for acceleration is meters per second squared. Third, rearrange everything s to the power minus 2. That's your base unit for force. Done. Let's try for energy. You can pause and try it yourself. If not, or if you have done, let's just see. So the derived unit for energy is joules. Now I am using the formula for the work done because energy is also in joules. You could use mgh, half mv square. Just to make life easy, I'm thinking of a formula for joules, which is force times distance. Now, force, we already have it here, which is kg meters s to the power minus 2 times distance, which is meters. So kg meters square s to the power minus 2. So what we're basically doing is we're trying to figure out what is the basic formula, and then we just convert the round unit into the base quantity. Okay, so now we're going to just talk about the next one, momentum. If you have tried already for the momentum, let's just do momentum is mass times velocity, first step. Second step, you write the mass in the base unit, which is kilograms. Then you write velocity in the base unit, which is meters per second. And then just rearrange kg meters second minus 1. Moment, I'm thinking of the formula force times distance. First step, base unit for force, we've just derived. kg meters s to the power minus 2. Base unit distance is m. So kg meter square s to the power minus 2. Done. Now let's go for the next one. Which of the following units could be used for power? So these are your actual exam questions. So I'm just going to think of my first step formula. Which formula can I use for power? Think of the simplest formula. Do not go for the complicated formulas because then your rearrangement part would become difficult. The simplest formula is energy over time. Energy, we just derived it earlier, so which is kg meter square s to the power minus 2. Time is s. Rearranging m square s minus 3. All is well. That's done. That's done. Pascal. Now, well, if it right now it would look like something difficult if you're in year 12, but if you're in year 13, you've done so many questions that you're very comfortable. Pascal is nothing but pressure. So that's my first step. Pressure is, now I'm thinking of the formula, simple formula, force divided by area. Force we know. So do you see how many times we have used force? So this is what happens when you practice enough. Nothing, things would start repeating, and then they would start getting comfortable in your mind. So do just do questions. Just do. If you do not understand, if you forget this, pause, go back, redo it. Redo the same things over and over till your mind starts making sense of it. Right? Is this part is correct? So sorry, this is not kg meter square. Meter square is for energy. So I have now just rearranging. That's what happens. If you talk and do, don't talk. When you're learning something, don't talk. When you're teaching something, don't talk. Well, let's do the errors. Now, this is the last part I'm doing today because longer videos, longer focus, difficult, difficult, difficult. So obviously when you're doing a practical, you're doing any kind of measurements, there will be chances of errors. Now for A-level physics, errors are divided into, not A-level physics, and even in physics, just physics, random errors and systematic errors. Now, I'm going to just make your life easy, just a shortcut to remember. Random errors are human errors. Humans are responsible for producing these errors. This is also humans, but not directly. So systematic errors is produced by your faulty equipments, okay, by a fault in the design of your experiment, faulty experiment design. Okay, so these are, for example, when you're trying to read or take a reading, the kind of error, let's say, for example, if you're trying to read a liquid and if you're taking the reading not here, so then there will be an error. So this kind of error is a parallax error. So the parallax error is a kind of systematic error. Or another example for systematic error is, let's say in the morning you get up and you decide that I want to take my weight today, but what you see in your weighing machine is, oh my god, it's not showing 0, it's showing 1 kg. Even before you're standing in it, it is showing 1 kg. So that error is zero error. It's the faulty equipment. And how do you get rid of the systematic error is, you, because it's a faulty equipment, every time there will be the same amount of error in the answer. So if your weighing machine is showing a 1 kg of zero error, and it shows, and you stand up on it and you get your weight as 66 kg, but then what would you do? What would your actual weight be? You'll take away one, isn't it? Your weighing machine was showing 1 kg before you stood up on it, and then you stood up and it shows 66 kg. So obviously you have to take away one. So somebody else comes up, stands up and he sees 76 kg, you take 1 kg away. Do you get it what I'm trying to say? So this systematic error is always by a same amount every time. But random errors, every time you take a reading, whatever errors you're doing, they're going to be different every time you take a reading. So that's why you reduce them by taking mean. You don't record them, you'd use a data logger to record them, then you'd reduce those chances of making errors. Or you, whenever you are trying to make any recordings in a experiment which is going on in continuation, then you record using a camera. So these are all the methods to reduce the random errors. Now these errors then would produce an uncertainty in your results. So about the uncertainty, we will try and talk about uncertainty in the next class. So till then, just in your mind, in your head, go over it, and till we start the next video on uncertainty. See you. Thank you.